This is what every code review looks like. A diff, maybe a title, maybe a description someone typed in 30 seconds after spending 6 hours writing the code. Your reviewer has no idea why you made this decision. No idea where you got stuck. No idea which lines the AI wrote and which you wrote. They're guessing. That's the problem. PRs have no memory. And to solve this problem, I built Trace. Hi, I'm Rahul, and this is my submission to the global online hackathon conducted by VideoDB. Trace watches your entire coding session, screen, microphone, every file save, and builds a searchable memory of how your code was actually written. When you open a PR, it generates everything: narrated walkthrough video, structured description, contribution map, reviewer Q&A, everything automatically. Let's see how it works. To use Trace, you have to type the command trace start before starting your coding session. This enables Trace to record your audio and video while you are coding. So you just saw me coding and recording through Trace. After I have completed my coding session, I have to type trace stop to stop the recording and process it and send it to the VideoDB server. Now, to create PR, generate video, write description, and post the contribution map, you have to run one command, which is trace generate, and then the session ID, and then your repo name. And as you can see, it has created a pull request. Trace has generated a structured description, what changed, why, and what the developer was struggling with, what needs to follow up. All is generated from the transcript and timeline. Now let's see the generated video summary.
Trace session summary. I tried to run the script, but I was getting a formatter error in my editor. When I ran it in the terminal anyway, it failed with a syntax error. The syntax error seemed to be coming from my greeter config data class. I decided to take a closer look at how I defined the fields to see what was wrong. I wasn't sure about the correct syntax for setting default values in a data class, so I pulled up the official Python documentation to check. After figuring out the data class defaults, I used an AI assistant to generate the code for a JSON config loader and a corresponding configuration file. I then tested what would happen if a user provided a style that wasn't in the config. To fix this, I'm starting by writing a failing test. I'm running the test now. It's failing with a key error for the grumpy style. The test fails because the grumpy style isn't defined in the dictionary. I'll have my AI assistant Claude fix the create function in greet.py to handle this case. I asked it to make the function fallback for unknown styles, log a warning, and keep the function signature the same. The AI is now implementing that change.
As you just saw, the video summary generated by Trace included all the important decision points and the points where the developer faced difficulties. This makes the review process much easier because the reviewer now knows the mentality and thinking behind a particular code change by the contributor. Let us see what else Trace generated. Trace has also generated a contribution map which shows how much percentage of the code has been generated by AI and how much the person has himself typed. As you can see, it has calculated here that 24% of the code I wrote was AI generated. Also, there is a reviewer focus mode, which tells if there are any high risk areas or major code changes which the reviewer needs to keep in mind. You can also start a backend server QA poll with a pull request URL and the session ID in the background. Then you can ask anything from Trace using the /trace command. You just need to comment /trace and your query in the comment below the PR. And as you can see, the server constantly polls and searches for /trace mentions every 30 seconds. And as you can see, he has answered in a comment. It has also included clips from the original recording which mention parts of your query. Now let us discuss how Trace has been implemented in the backend. At the users and application layer, the developer codes and narrates aloud his thinking process while running the trace start command in the background. The trace CLI then captures the screen and the mic using different methods depending on the OS. Like currently I'm on Arch Linux, Hyperland to be precise. So I had to create a separate pipeline of processing before using the capture client SDK directly, as it is not supported for Linux. So what I did was I captured my screen using WF recorder, which is a recorder for screen recorder for VLAN, and I captured my mic using FFmpeg and Pulse Audio. And these also I have modified according to my OS. In the macOS and Windows, the VideoDB capture client SDK should work fine. Then all of this data is fed into the live indexer, which sends the MP4 chunks every 15 seconds to the VideoDB indexer. The indexer then indexes the spoken words and the scenes. Then there is a semantic searching mechanism which searches the spoken and scene indices. Then I have used the voice generate feature of VideoDB to generate the voiceovers over the summary videos you just saw. Then the editor also sees the timeline and tracks of the different components generated. Then after this layer, the outputs are sent to the processing and features layer, which includes the timeline builder, the PR video narrator, the PR descriptor, the /trace bot, and the contribution map we just saw. So the timeline builder takes all of this index data and prioritizes the clips to be included in the final summary video. And then all these features combine together, and through the GitHub API, they get generated in the form of a PR to the repo submitted by the user. Some things are also stored in the local storage and the VideoDB cloud while the processing. I hope you like my project, and I'm open to any feedback or suggestion. Thank you for reviewing my project.